So, what is a package in last week we talked about packages.
Collection of data sets.
Okay, good. How do we obtain a data set? Sorry, a package in how do we obtain it or have access to it, and also how do we have access to it once you are able, or in other words, how are you able to install it, and then when you install it, how do you okay. Yes. From packages. How do you do that? Yes. Mm-hmm. Yes. Yes. Okay. So there's a package called Zelig. I want all of you to install it. You did it? Yes. Okay, so then we are good to go. Yes. I have started. Before you said so. Okay. All right, okay, so good. Okay, so now, I wrote weed. Not now. We can. Today is on 19th, okay. Okay, so today we are going to talk about data structures and data types. Please, those at the back, can you see? No. Is it better? It's okay now? Okay, good. So we're going to talk about data structures and data types. Okay. So I'm going to show over here what we mean by a structure. We're going to because we are doing statistics, we're going to deal with data. Now, if we are going to deal with data, then in the package that we are going to use, we must know how a data is stored. So I have given you some data now for you to download and get it into R. We will know how to get it into R soon, but we must know about the structure of the data so that when we have it in R, we'll be able to work on it. So the data structures. So we have basically 5. I'm going to treat 4 of them quite sure. The other one I'll just mention it. And if they are. Okay. So the first one is called a vector. Who has heard of a vector before? Vector. You did it when? Last week we talked about it. Yeah, so okay. So let me go. Then you know. So tell me. You said we did it last week. Okay. Yes, vector. Yes. It is what? It is what? It is what?
It takes 1 data time.
It takes 1 data time. Okay, that's one characteristic. What else?
One dimensional.
It's one dimensional. Okay. So in representation, we can have it like this, or in math, you see we have what? Either column or what? Row vector, right? So that's it. So it's one dimensional, which means it should be of this form. And each of the things over here must be of what? One word. Data type. Did I talk about data types?
Yes.
One data.
Yes.
Okay. So I thought we were far behind. Not knowing I've done everything. Okay. So I think I explained, right? But we did not, as we said, not go into detail that much. Okay. So let me move on quite quickly so that we can move on. What about a matrix? What about a matrix? Yes. As for this one, if you come at the weekend, and then the next weekend, if you come here and you are now looking at it, I bet you that you will always be behind. You need constant practice. You forget. That's it. So you need to practice during the week, but these are very crucial. So please, let's make sure that we revise before we come. Yes. What about a matrix? Yes.
It's a one data variable.
One data. What do you mean by one data variable? Yes. What is a matrix? Combination of vectors. Good. So if we combine vectors, they become, so how would it look like? So you know all this. And you didn't want to talk. Okay, so M by, so essentially we have a box like this, so we have what? Rows and what? Okay, good. So that's the structure of it. Yeah.
I think you also said it's a rectangular array.
It's a rectangular array. That's also fine. Yes. What else? The other characteristic, you said one variable. You were close to something, but that's not it. One word. Yes, it also contains what? One data type. Is that okay?
Yeah.
Oh, okay, so that's the characteristic. Also one data type like that. Okay. Then 3. We talked about what? Data what? Frames. We said data frames are also what? Yes. Data frames. So what is the structure? You forgot it. Oh, we just talked about one time. This is a structure, right? Which is one dimension. This one is a structure, that's also 2 dimensions. What about a data frame? It's 3 dimensions. Hey, but there's no material, so it should be 3 dimensions. So that when we get to 4, we get 4 dimensions. Okay, yes. Yes. It also has rows and columns. So it's just like this, right? Okay. What else? What else is peculiar to this one? What distinguishes data frame from a matrix? The data types, okay. What did we say about data frames? That is, they can contain what? Different data types. Good. Okay. So the data types what? Can be different. Okay. So it means we may have age here, but we may have religion also here. Is that okay? We can have sex, we can have weight, or whether you vote for a particular party or not. But this one, We cannot have different data types like that. Okay. And then lastly, we have what? Is it 4 dimensions? This one is 4 dimensions. What about this one? Is of this what type? It can contain, it's 1 dimensional, but it can contain all different data types as well as data or structure. So that's it. Is everybody okay? Okay. Then we also talk about the data type. So let's quickly review it and then we can go on to the data types. What are they? One is what? Numeric, right? Data types. So we have what? Numeric. We are going to see this. If you have opened the credit card data, you will see amount and so forth. Okay. Or balance that. These are all numeric values. Is that okay? Then 2. So 1 numeric, 2. We have what? Character. What else? 3. Missing values. That we represent it with what? Any. Good. 4. Factors. Did I put a book R reduction on your page? No. Not yet. You have to check. Whenever they say ASTA, you are part of it. Okay, but I'll show you very soon. 5 is what? So what did I say about factors? They are nominal, yeah, and ordinal. So we can take either numeric or characters and then we can use factor to create what we call the nominal level variable or an ordinal level variable. And we'll see how this is done soon. Then 5. Dates or time. What else? 6. Logical. What are logical? True or false. Okay, so this is that. And did we? I think I mentioned it, but we couldn't create any of them. So what we are going to do is to quickly look at how we can create these data types. And then we can read our data. Okay. So if you look at the credit card data, it's here. So limit balance, limit bar is a vector, right? Limit balance alone is what? It's a vector. Is everybody okay? All right. Now, what we are going to do is that this one has already been created in R. But what if I have a data set and I want to create a vector? What do I do? Is everybody okay? So that's what we're going to do now. So 1, vectors. Okay. So there are so many ways to create a vector, but the main thing we do is to use the function C. So I'll talk about 3 things. We can use C, the function C. We can use colon. We can also use replicate to create a function. Sorry, a vector. Any of these? Yes.
No, please, are you recording?
Yes, please. Why? Is it because of the replicate? Okay. All right, so let's move on. Yeah. Okay. So now let's move on. So let's say we've asked 5 people, the ladies, they won't want to tell us their ages. So the men, if you want to tell them, you can also mention any age. Even if it's 100, we will accept. Yes, first number. So I'm using the C. We call the C combined. Okay, it's combined. If you want to know what it is, you can also question mark. You say anything you don't know, what do? You question mark. So this is small letter C. So let's question mark it. What does it say? It combines values into what? A vector or a list. Remember, vector and list are almost the same. The only difference between them is that a list can contain different data structures, whereas a vector contains just one data type. Okay. So we can use C to combine list or what? Okay. So now let's see. So age, just type in, what you have to do is to type in the numbers. You use comma to separate them. Is that okay? All right. So maybe the first person is 28 years. The next person is 67. The person is not in this room. 24. Or somebody is 67. Who is that? Who? And then maybe 25. Okay. So when you finish, you run this. And then, if you go to your environment, you see that age is there. Is that okay? All right. Now, I want you to create weights for these people. Your numbers must be realistic. In other words, you cannot give us negative weight unless you are in space. So do that, and then also did I leave my okay, and then when you finish the religion of these people, remember the religion, you have to put it into what? Quotation marks, because they will be what? Characters. Okay. So quickly do those two. Let me pick my pointer. So religion and weights. Are you done? And you have all your objects on the environment. You are not done. A small letter. Yeah, you run it to see what. Yes. Your it can't run.
They say it's good for the run.
You haven't written. Oh, is it? Oh, but you need to put them in quotation marks. And it must be the same as the number so that we can combine them. The numbers are 5. Your C is in no capital, which is more So why are we doing this? The objective is that if you have a data you want to enter on your own, then you need to. Yes, it is telling me that what is the home. You check. No, you run only the numbers. That's the problem. You have to run them together. So put the cursor anywhere, don't highlight. Yes, and run. Yes, separate. But they should be of the same number. That's no, you have to put it in quotation mark. Remember, this are right in the start. So just get 5. So each of them 5, 5, 5. So maybe they are 9. Please, are we okay? Can we move on? Okay, so let's see, you have done. Okay, so hurry up. Just type any number. Wait, yeah, wait. 85. Okay. I want us to create so that we can move on. Other than that, Okay, so that, you see, if you look over here, you will see now, that means it's all numeric, right? The religion shows at all. Character, good. Okay. Now, you should also create logical. So 5 of them. So, maybe that is vote. The logicals name it vote. So you are checking whether all these 3 people, they will vote. They say true or false. Or voted. We ask them whether they voted in the last election. So voted, create a vector that is also 5. Okay, but it made up of logicals, which means true or false, right? You can write true, or in caps, or false, or in caps, or you can just use T and F. T for true, of course, all of them capital. T for true, F for false. Yes. Yes, it's still
Yes, true or false.
Yes, also fine. So T, maybe comma, false, comma, like that. No. Because it's logical, it's actually a data type. Yeah, so R knows that true. If you type it, it will be blue. So either T or M. And you see that the color is blue.
Let's see how you
Now you put them in quotation mark. Each of these in quotation mark. So let's double click on it. And then
no, don't put it in
so always work within the brackets of our so anybody that is facing problem, we are all okay. So the logic and the logicals and what do you see? Okay. Yes. No. That one is recognized by R. So T. Yes, what happened? No, I think your C is capital. Okay, so let me also do my own. So wait. You started probability, right? Yes. Have you talked about probability distribution? No. Not yet. You've not reached it. Okay, so I'll tell you that there's a probability distribution. A probability distribution is just, let's say if it is discrete, the list of possible outcomes and the probability assigned to it. Okay. So we call a probability, one probability distribution is called uniform. Okay, it's like a rectangular shape. So let's say if, this one you can see. So if we write a test, and the test is between 0 to 30, and we say that everybody has an equal chance, okay, of scoring any of these, we can actually have if there's a uniform chance, then each of us has this probability. So maybe this probability is, let's say, 1/3, right? So it means that we have a box like that. Okay. So what am I trying to say? You listed your weight, maybe 80, 120, 90. So I can also randomly choose weight within this range. In other words, maybe within the range, uniformly distributed between, let's say, 70 to 120. So I can choose 5 numbers from you. Or later on, we've not yet chosen lotto numbers, right? Not yet. You want us to choose it? Yes. Don't go and take it. If we I would have been. We've done it? Yes. Okay. So let's move on. So then you even know all what I'm talking about. Okay. So I can also, or let's say I'll sample rather. I think sampling will be easier because that you have done. So the uniform one I was going to say is also random sampling. But I'm not sampling from numbers, I'm sampling from the probability distribution. So you've seen sample before, so let me use a uniform distribution. So our unif, so this is it. It says uniform distribution, minimum value and maximum value. So I choose, what number do I want to choose? I said 5, right? The minimum weight may be 70, the maximum weight is what? 120. So I can also, this is also random sampling. So sometimes we may sample from actual values, sometimes we can use probability distributions to generate the random numbers. Okay, so I do this, it still gives me a clue. So I put in n is equal to 5, the min is equal to 70, it means nobody is less than what? 70 kg. And then the maximum is equal to 120. So I ran this, I also have weight. So you see my weight, the weight of my 81.86, 79, 96, 103, 113. But remember, this one has what? 5 decimal places, right? Okay. I can even round it off. The same thing we do. Your own, was it one whole numbers? Okay. So me, I can round it to 0. So it means I also have, I rounded it to digits. Actually, it's a round. Digits. Is it digits is equal to 0, like that. If I rerun it, I'm going to get different values because each time this is random number generation, right? And so forth. So that's it with it. But the main thing is that this is also what? Numeric vector. Okay. And then you did religion. So religion, we have C. Maybe Christian. So CR, so Chris is Christian. Mos is Muslim. The next one is also Muslim. The next one is traditionalist. The next one is Christian. So in that case, I can just copy paste. And I'm done. I'm not saying your own should be like mine. Okay. Okay. So religion is what? Character. Is everybody okay? All right. Okay. So that's a vector. That's a vector. Please don't lose track why we are doing this. I said sometimes you have collected data, you want to enter it into R. When we finish, we'll see how we can also enter it through Excel and so forth. R is not a good place to be entering numbers. If you have a large data set, you do it in Excel because it's easy. Excel, I'm not going to do comma, this, and so forth. I just enter them, just like that. After that, we'll read it into R. So this is just to show you that we can actually do it in R, but it's more tedious, so it's not advisable. Okay. Now, I want to use this to create vectors, matrices. So now we move on to what? Matrices. Remember matrix, we said they contain the same data type, right? Oh, I did not do the logicals. That was what? Voted. So that I can okay, so this one I want to combine false with, you see, I talked about rep, right? Rep is replicate. So that replicate can take on anything that I put there, I can repeat. It's just replicate is repeating, right? Okay, so I have true and false. So I want to do this 2 times. So this is what I'm doing. Take true, 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 false, and repeat it. So I'm going to get true, false, true, false. Are you with me? Yes. So that's a replicate. So replicate can also create a vector. Is that okay? Yeah, I cannot replicate 2 things and I get 5. That's why there's the first one, I put something there. Do you get what I'm saying? Yeah. If there were 6, I could have just replicated this how many times? 3 times. Yeah, so I said the first one is F, then I replicate this. So that replication, how many times? That 2 there actually should be times equal to 2. So it means that replicate what I have over there 2 times. Okay. And then I get 4. If I put all these together, I'm going to get what? 5. Okay. Maybe we should do, what is this? If I have 1 to 3, Who can tell me what will happen? One. How? Okay, good. Okay. All right. So if we do this, 1, 2, 3, 1, 2, 3, 1, 2, 3. Is everybody okay with it? So you can actually use replicate to also create what? A vector. So that's it. Okay. So let me do my own voted. And that's also logic is what? Logical. Okay. Don't worry, you've done your own, and I'll make this available to you too so you can practice it. Just get to know what these are. And of course, the colon is what I have also used here. So that colon also says 1, 2, 3, right? So colon can also be used to what? To create what? A vector. I can do 10 to 3. 10 to 3. What do you think will be the answer? 10, yes. 10 what? 9, good. And so forth up to what? 3. So the colon actually gives you, it counts in steps of 1, either backwards or what? Forward. Or increasing order or decreasing order. Okay. We can even generalize it with, I did not add that one, with sequence. I don't want us to be going into too much details. So there's also sequence. So we can move in different orders. Okay? The column moves in steps of 1. What if I want to move in steps of 0.01? Then I can do sequence. So the sequence, I move from 2 by what steps? So you can check it if you want to, but I don't want us to waste time on it now. So SEQ, S-E-Q, is sequence. How to generate a sequence. Okay, so here, if you come down here, you see what? From this. So let me just demonstrate so that, so let's say I want to move from, let's say 1 to 20, but I want to move in steps of 0.1, which means I'll get 1, 1.1, 1.2, 1.3, 1.4. So if I run this, I'm going to get that exactly. So they are almost what, 100 steps. Okay, so that's sequence. This is a more general form other than what the column. Okay, so please take note of that. And the result of it is a vector. Okay, so if I say this is IND and I run this, if I go here, I'll see IND as what? Numeric vector made up of what? 191 numeric values. So that's it with it. Okay. Now, someone, I want to move on to matrices. Someone said, who said you combine? When I asked on matrices, one of you said you combine. Who said that? Was it you?
I said
Columns and
yeah.
Amma, you said we combine the rows and columns. I'm not coming to ask you questions. Okay, so essentially, we can actually combine vectors to form a matrix. That's what I want to retrieve. And she doesn't want to own up. Okay, so one way to create a matrix is that we can either column bind them, which means we attach columns, right? And we can also row bind them, in which we attach rows by rows. Okay, so for example, we have age and weight, right? Okay, so I can So we can create matrix with one C bind, that is a column wise bind. Then we have also R bind, that will be what? Row wise. Okay. And we can have what? Matrix. We can also use matrix function to do it. So any of these three can be used to create a matrix. So the first one, A, is that I can do column bind, C bind. You see it's already in. So I select C bind, age, and what? Weight. So when I do this, what do you expect? The result should be what? In a matrix. What will be the dimension of this matrix?
5 by 2.
5 by 2. Good. Okay, so let's see. It's exactly this, what you said. So the age of the first person, the age of the second person, and so forth. Okay. Then I can also do row bind. What do you think will happen? It will become what? Good, yeah. So I could have obtained the same thing by using T. Do you know what transpose is? So the mathematics transpose is the same as T in R. So in R, T is transpose. Okay, so that's it. Or in other words, if I name this as OA, then OA is a 2 by what? Sorry, a 5 by 2 matrix. So the transpose of OA is what? Is a 2. So you change the rows to become what? Columns. And so forth. So that's it with row bind and R bind. B is when you use a matrix. I am very brief with this because most of the things we'll be doing will be to read it from. So I don't want us to spend so much time, just to know that we can do this. Okay, so this is C bind and R bind. Okay. So matrix. So when you want to create a matrix with the function matrix, then you must have a long vector that you want to break into pieces, right? Okay, so I'm going to create numbers, and these numbers are 1 to 20. Okay, so I have a long list of numbers 1, 2, 3 up to what? 20. Now, what I want to do is to create a matrix, okay, from this. So how do I do this? Well, I'll call, let's do help files for matrix. So matrix, it creates a matrix from what? A set of what? Values. So look at this usage. You need the data, you need the number of rows, you need the number of columns. Okay. So let's see. So let's say math is our matrix. So this matrix will be made up of what? The numbers. Okay. How many rows do we want? They are made up of 20, so maybe we want 5 rows. Then the columns will be what? Good. So I'll take them names off. and leave these ones intact. By row is false. So I'm going to explain the argument by row. If by row is false, the matrix will be formed column-wise, right? So the first column, the second column, the third column, and so forth. So let's see how this will look like. So it means I'm going to have 1, 2, 3, 4, 5, 6, 7, like that. Okay, so there it is. Now, what do you think will happen if by row is true? So fill it row-wise, which means I have 1, 2, 3, 4, 5. Oh no, 1, 2, 3, 4. Then I can 5, 6, 7, 8. Then continue like that. Okay, so math, and then let's look at math 1 where row is false. This is true. So let's see. Oh, I have overwritten it. Math 1 and math 2. So let's look at math 1. So you see, when by row is true, it is filled row-wise. If by row is false, it is filled column-wise. So basically, that's it with matrices. But remember that matrices contains the same data type. That's why in this case, it is only numeric. Now we move on to data frame. Any question before we move on? Very fast. Take your time. Take your time and do it. Let me scroll down a bit. So this is it. You are all at the matrix session. Okay, so take your time and do it. And observe what is going on. If the typing is slow, you get the mistake on. At the time I start typing, you are not ready. Okay, are you done now? Hey. No, you have to copy and paste. Once you have done it, you are not necessary. So you have to create them and then before you can create it. Anybody that needs assistance? No. But I mean, this is, we won't do this, so that's why I said if you want to do it, you do it the next time. Yes. So, when remember we did age and weight, right? We could have given you the entire data in one text. Maybe the first 5 is age, the next 5 is your then we say create them. Create a bit. So if you are creating that, you have to know how to do it. You say, why we go through this. But in that case, you don't know the first one, this one is 5 and the other is 5. You do it by column. So all this one will be 1 page, the other one. So if by row is 2, it means fill it row. By row is 4, so it means fill it column. Okay. Okay, so that's a matrix. Now let's do this. Please, let's all look here so we want to create. So you see there are 3 ways you can create a matrix. Now we want to create another matrix too, which is called, I want you to tell me what will happen before I even start. Age, weight, religion. What will happen? It will be, why will it be a data frame? Okay, so let's see. So run it and check whether it will be a data frame. So let's go and check MAT2. MAT2 is what? It's character. Who can explain why? So this is MAT2. Just copy what you did up there and then you add religion to it. Why has it changed all of them to character? Because yes. Because a matrix can only take what? 1 data type. So if I'm mixing characters with what? Numbers, what will it do? It will only take the characters. All the numbers will be converted to what? Characters. So that's it. So actually we should be using what? A data frame to combine this data. Is everybody okay with it? Yes. Good, okay. So now we can move on to talk about data frames. So what is data frames? Well, to create it, so we create a data frame with data.frame. Okay. So the same thing we did, just go and copy MAT2 and now paste it here. Then instead of cbind, what are you going to replace it with? I'm copying and pasting. That's why it looks that I'm so fast. Don't type again. Just copy and paste. So MAT2, now we will have df mat. Data frame mat. And when I do this, it tells me that this is data frame. Five observations on what? 3 variables. So when I display this, you see every vector has retained this one, its form or its data type. Like that. Oh, you can't see what is up. Okay, so there. So let's do that and display this and see what. done? Yes, copy paste. That is what how we do. If you type it, you are ignoring. The same issue. So let's see whether it is enough. Anyone that needs assistance? If you need assistance, you let me know. Yes. And so here display the DF mat. If you have an object, you can even look at it over your switch, right? So if you double click on it, it will display. Double click on the DF mat. Yes, click on it. Yes. So, yes, it's there. Okay, so double click on it. So this is. You have to see it on this video. All right. Okay, so I think we all have it now. So that's a data frame. If you have different use was data.frame, and then we have it. Okay. Then let's do the list, and then we move on to more practical stuff. Okay. So the next one will be what? List. So what is a list? We said it's the most complex data you have. It can contain different data types and data structures. So what we are going to do is that we will look into our environment. We can put everything we have done into a list. Is everybody okay? And remember, they say we can create a list with even what? The C. But we are going to use the function list. Okay. So we call this my list is list. Then put anything in. So I can put a vector. So I'm just doing vector dot numeric vector, right? So let me just say, I just want to say that we can have what? Or show that we can have different data types in there. So the numeric data, I can do age, and then character vector. The character vector we've done is all religion, right? Yeah. Then you select. Next one, we've done matrix, right? What was the matrix? You see, each of the matrix was math. Okay, so I can math. And then what else? Data frame, right? Data frame is what? DF math. Okay, then I select. Okay. What else? Then we have logicals, right? So the logical data we have what? Voted. Then you select. Each of them I'm selecting. Type you select, and so forth. So let's see. My list is this. And then I've created a list. List of what? 5 objects. My list is an assigned list. Then you have just to say numeric vector. Numeric vector. Then equal to, then you select the vector. If I do that, I need to show that. That's why I break it. When you program like this, you can see all of them. Otherwise, sometimes you have to show the one here. So you can, after the comma, you can press enter and it brings you to the message. Are we done? I said, I'm going to get a baby one and put it on the. After work, you come and sit down. By next week, you try 30 words. Are we done? If you're having problems, you let me know. So that I needed to give you attendance. Let me click it so that you can sign. Yes. Okay, I'm bringing your attendance. Are you done? Hey, I'm sure people are typing everything there. Remember? I said select. As soon as you start typing, especially the data, it will appear, then you select. Because some of you use religion with small r. Yeah, so you have to select your own, not yes, you're right. I'm just using the vector to show that this is a vector. This is a vector, but it should have been age. I should have just said age, yes. Yeah, once it's a vector, you can just age this, that, I'm just showing you that. Because your vote, I think, is capital, so so you have to select no time. Okay, so delete the video. And now rerun it again. Just run. Go to run. Okay, so display it. Okay, so you have to always type. But as soon as you see not found, then you know that you have not defined that variable. So it will be that sometimes if the spelling is the same, you need to check whether there is a capital and you made it small, or the spelling is not right, correspond to the and so forth. Yes. Yes. You're okay. Okay. So now we know all the data types. Is that okay? Now in R, data sets are usually stored as data frames. Okay? Some are also matrices, and some may be vectors. Okay? But usually, you have data frames. Okay. So I'm going to show you some that we have in there, and then how we can obtain values or objects from it. I want us to move away from this a bit and get practical more so that people will appreciate whatever we are doing. But I'm left it how to retrieve objects from each of these. So for example, if I ask you to, you see we talk about age, religion and so forth, but we don't know whose age is the 28. Who is this and so forth. Okay? We can name them and be able to retrieve them. Is that okay? So we'll do that before we move on. So naming objects in data structures. Okay. Once we do this, we can now retrieve with them. Okay. So for vectors, use name. Okay. So a vector like age, we can talk about names. Oh, I think it's names, right? names rather, sorry, names. So names of age, if your age you use small letter, you have to use small letter, otherwise it won't work. So names will be what? Will they be numbers or characters? Characters, yes. So maybe the first person is Amma, the next person is, oh, Amma is here. Abba, is Abba here? We want only 3-letter names. Ali, is Ali here? Which one again? Oh no, it's Abu. Is it Adado's own? That one is double D. You are not afraid of your president. Democracy. So now let's go ahead and look at age in our data set. What do we see? It's a named num, which means age contains numeric values, which are what? Name. Okay. So now if we call age, you see that it gives us Ahmed's age, Abba's age, Ali, Abu, and all, Adam. Okay. Now, if it is matrix and data frames, we use call names and row names. And we do the same thing as we did in the vectors. Okay, so for matrices and data frames, use call names, of course, call names will be for all the columns. And remember, we have 2. So if you have call names, you should have what? Row names. Row names. So this is what we'll use for them. And if we say row names, we give the rows the same name. So for example, let's say our row names for where is our, let's see. Okay, so the row names for, let's say, DF Math, right? DF Math. That one was our data frame. We can give it the names of what we have done. So I can copy the same things. So please don't type. Just come and copy and put it there. So row names of DF Math is this. Then if we display DF Math, we will have it in this form. You see the age of Amma. And this is the sort of data we usually encounter. The columns are what? The variables, and the rows are what? The values. So we've already done DF Math. So what I did was to give it. So Amma is 28 years. Amma's weight is 112. Oh, religion is what? Christian. Ali is 67. Ali's weight is 105. And Ali is a Muslim. So that's the sort of thing we can. Then we can also name the column, but this one, the columns are named already. So there's no. So that if it is a list, we can use names because it's the same as a vector. So that's it. The next thing is how to retrieve observation from it. So for example, if you want to retrieve observation, we use the square bracket. So if I want Ahmed's age, then it means I need the row number. I can use the row number and the column number. So Amma is row 1 and column 1. So I'll put in the square bracket 1, 1. Okay, so I call DF Math into square bracket 1, comma 1. That will give me Ames age. If I want Ames related, it will be what? 1 and what? 3. 1, comma 3. If I want Abu's weight, it will be what? 4, comma 2. Yes, but if you have a data set that has the one that I've given you, the 30,000, the credit card, you cannot be doing these numbers. Okay? Yes, so that you can use a name to set for it. Okay. So instead of Abu 4, I would rather do the DF man, then into brackets Abu in quotation marks, comma, then what do weight in quotation, then it will retrieve Abu's weight. That is more convenient in a data set when you have a big structure. So let me just do that and then we can now move on. I'm not going to do any of this technical stuff again, then we can move on to our data. So we call this subscripting or, okay, the subscripting with data structures. Data structures. What do I mean by this? It's just like selecting observations. That's what I mean. Or selecting observations. Or selecting objects from data structures. That's so for example, what is Ames age? Amma, they say your age is 28. Who gave us the age? Okay, so what is Ames age? We will call DF mat, right? Let me just add that use square brackets so that it helps you to know. So whenever you see square brackets, it means you are retrieving something, either selecting or retrieving observations. So DF maths, we said 1 and what? 1. So let's see what happens. We run this. This is 28, isn't it? Yeah. Okay. Now we could have also used Ames name and what? So the same thing, we can use it as well. What is the age, right? Age, no. The row name is what? Amma. And the column name is what? Age. Like that. And that also gives me 20. So I said this is more better if you have data set that's 30,000. You cannot be looking through rows. Okay, these are customers. So the customer comes and give you, let's say, the ID number. Then that's unique, so you can use it to the ID number may not be a number, sort of. In some cases, ID numbers are characters. They may have numbers and alphabets as well, or even Greek. Any question? So that's how we will retrieve observations from the room. do. Okay, so let us move on. We will do some of these things. We can even check who is over 50 years. So the data that we have, if we want to check who is over 50 years, we need to put, that will not be assignment, but we need to check age greater than 50. Yes. And I want her to start reading data. You see the plus, and it is not prompt. If you have done it, you should see it. You have not done the road. You see this? That's why it is. So now, we will do some of these things, how to retrieve observations in data sets. So I want to show you some data sets in now, and then everybody has time. You have to make sure you send everybody. Okay. So let's look at a real data set in R. That is in a matrix form. Okay. Now let's look at dim. Everybody should look dim. Is it dimension of an object? Okay, dim is dimension of an object. So if we have a matrix, what will be the dimension? Okay, rows by columns, right? Okay, so let's look at DF math. DF math will be what? Is it 5 by 2, right? 5 by 3, because you have 5 rows and what? 5 columns. So There's also a data set called state. So start typing state x77. State.x77. So this is a data set that has dimensions 50 by all 8. What can you say about this data? It has what? 50 rows, 8 columns. The columns are what? The columns will be what? As variables, yes. And the rows? No, numeric. The rows will be what? The entries or the various observations. Okay, like you see Amma, then you have Amma's age. Age is a variable, but Amma is not a variable. Is that okay? Yeah, so that's what we mean by this. Okay. Now, let's also look at structure. The structure, of course, will be, we've done data structures. So if we want to check the structure, it means we want to check what data structure is it. So if we want to get the structure of the data set, we use str. Structure. So let's look at structure of state x77. So it says this is what? Numeric. You see our selection. The square bracket is what? Selection. So it is telling you that this has 50 rows and what? 8 columns. So 1 to 50 means 1, 2, 3 up to what? 50. 1 is to 8 means 1, 2, 3 up to what? 8. So once you see this, then it is telling you that this is what? A matrix. If it's a data frame, we're going to see a different thing. So let's look at data frame. We look at the structure of DF mat. So it tells you that this is what? Data frame, right? It has 5 observations of what? 3 variables. So that's how we see the structure of the data. If we do what my list, what do you think it will be? My list will be what? Of course, a list. So it's a list of all 5. Yeah, so that's what these are. Okay. So we're going to look at state x77. So you must shift your this thing here so that you have enough space to look at the data. So let's all highlight this and state.s77. Please don't, as soon as you start typing it will come, then you select. Don't type on your own. You will make mistakes. So this is it. My destiny is so big, so you can't. So these are states in the United States of America. And you have the population. You see, everything in here is numbers. That's why it is stored as what? A matrix. You have the population, Alabama, Alaska, Arizona, Arkansas, California, Colorado, Connecticut, and so forth. Every state, Delaware, Florida, Georgia, Hawaii, and so forth. To warm. Is everybody okay with this? Yes. So this is rectangular data, and it's in a matrix form because we have all the values being what? Numbers. Okay. Have you been able to display it? Okay. Now, so this is a matrix. Maybe let me. Matrix. Then let's look at data frames. So data frame. Let's go to, okay, so another way to load a package we said is what? Library, right? So let's try and do library mass. That is the same as going to the packages and taking what? Mass. So let's do library mass. As soon as you finish, start typing this, anorexia. And as soon as you start, if I even put it on it, it tells me that anorexia is what? The anorexia data frame. So this is a data frame that is stored in R. Okay. It has 72 rows, 3 columns. The weight change data for young female anorexia patient. So look at this one. You see we have characters in there. But these are factors, actually. Factors. So there's treatment, there's pre-weight and post-weight. Pre-weight and post-weight are numeric. But this one is groupings. And it's actually under the nominal scale of measure. So that's it. So these are all inbuilt data sets. So in exam, sometimes I can tell you that there is a data set in this package, which means for you to be able to use it, you need to either use library or you go to the packaging side and take it. If you don't, you won't have access to the data. Is everybody okay? When you finish, type insurance. When you start typing, it will appear, then you select. That's also a data set. Have you seen it?
Yes.
What does it say?
Number of cars, insurance.
Good. Okay. So these are all real data sets that are all inbuilt now. And we will come back to it. Now let's see how we can import data, and then we'll do some computations and maybe some graphs before we go. Okay. So this is it. If you want to display it, you just run it. Everything will be displayed on the console. Okay. We'll come back to this data set. And I talked of insurance. So if you start typing insurance, and it says, oh, the data given. This is also in what? A data frame, right? Okay. It consists of numbers of policyholders of an insurance company who are exposed to what? Risk, and the numbers of cards and so forth. So you have the district, you have the group, you have the age group, you have the holders, and the claims. Okay, so that's it. Okay. Now, let's go back to, now we are going to talk about importing data into R. Please, is everybody following? Importing data into R. Now, when you have a data set, whether it's online or if it is online or if it is in Excel, you can read it straight into R. So, as I said, it is not pleasant to be typing data into R. You can do so quite easily in Excel, and then you import it into R. Okay. So, we're going to see how to import data from Excel. Okay. So, go to the data I gave you, and then the credit card data, you can rename it, okay? It's too long. Then there is the iris data as well. Unzip it. And if you unzip it, you have all these data set. That one is already in R. So let's just use a oh, sorry. Okay, so let's just use the credit card data. So the credit card data is quite a big data. It made about 30,000 observations. And they are bank customers in Singapore, right? So the data, where did I even get it? I think it's one of the universities in US. It's online. So if you look at it, this is a customer one. Customer one's limit balance is 20,000. Sex is 2. So which means these 2 is what type of data? It's all a nominal. Yeah, the scale of measurement is nominal. Yeah, the 2 may represent male or what? Female, and so forth. What about educational level? 2, 1, 3. Are you sure? It's ordinal. Yeah, the scale of measurement is ordinal. There are actually 7 of them. 0, 1, 2, 3, up to 6. Which means 0 may mean what? The person has not been to no formal education, and so forth. Okay. Then this is marriage or marital status. 1, 2, 3. Nominal, good. Age. Age is also nominal. This one, 24, 26. No. Is age qualitative or quantitative data? So it cannot be nominal or ordinal. It is what? Ratio, good, and so forth. Okay. So this one, pay 0, pay 2, pay 3, pay 4, pay 5, pay 6. I think, I don't know what it is, so I'll just delete it from there. I think it's whether the person paid in the, but we have bill amount, bill amount 1, bill amount 2, and so forth. Yeah, so how do we read this data into R? Well, it's simple. Let's go there into R. So at your environment, you have import. Look at import. It's actually import data set, right? That's where we use to import the data. So if you click over there, you have what? From SPSS, if you know SPSS, and we have data that we can retrieve it. We can also do from SAS and also from Stata and Excel. But we see Excel there, so what do? We click on that one. Then we have to browse. So we do so. So when you browse, you must go to where so you see, I searched and I went to the folder, I have it in there, and the credit card client's data is there. Please, are you following? Okay, so you double click on it. Because the data is quite big, it will take some time. In your case, it will be searching for a package. There's read Excel. So if you have not used it before, no, the data is what was put on your, and you have it. So save it in the folder. You have it in your folder, where the class folder. You have it. Then you go to R and let's see. You have to save it in your folder. Go to R. Are you sure this is in your folder? No. Save it in the folder you have R. So go back to the Excel file. Please, have you been able to read it?
Yes, sir.
When you must change the name. The name is too long. Okay, so when you get here, once you get a preview, when you scroll down, you see the name. So you must maybe say credit card. Simple. Otherwise, when we are in that and want to do anything, you have to type all that name. Is everybody okay? Yeah, so credit card, and then you click on what? Import. Once you click on import, the name is too long. So just change it, shorten it to credit card. Yeah, so just only credit card. Yeah, credit card. Yeah. Yes, you can now assign that long name to credit card. So it's just an assignment system, which means you have double of the system. You can also re-import, it will override. No, it won't. Because it's only when it is coming as the same name that it will override. You have to assign it a different name before you delete the long name. Yes, you can also delete it. If you want to delete it, you can use RM. So RM, the name of the yes. You can't delete it from well, you can also delete it from your environment. Let's see. If you want to rename, let's say my own is what? Credit underscore card. If I want to name it just credit card, let's say credit card. Okay, what I need to do is just to assign this credit. So as I start typing, it will appear yes. So like this. So it means you have two copies, right? And then I want to remove credit card. So I can just start typing. Once it is the underscore one, I want to remove it. So I click like this. There, it's removed. That's it. That's how you remove observation from it. So the key thing is that once you do this, you have this data read into it. Now, if the data is also stored as, let me go to this. Okay, if you look at it, it's what? 5 megabytes, right? 4.3 something kilobytes. Now, I can copy all this and paste it in Notepad. You know Notepad? Yeah, Notepad is quite simple. I can just create a Notepad. Yes, copy and paste. Just get Notepad. Oh. Yeah, just copy and paste in Notepad and save it in the same folder. It will come as a big data like this. Then you save it in the same folder. What is the folder? Desktop. Yes. And I call this, what was the name of the credit card? Okay, so let's say this is test credit. Okay, I want to go to the test credit. It's for, so you see it has reduced by about 2, right? 2, it's been reduced to about 2, like by half, 50%. Okay, so what we mean is that you can also have a data set that is also in what? In a test format. If you want to do it, it's the same process, but you use the first one from test, and then you read it, just like we did for example. In the Excel, file, if you want to copy, you go to the Excel, not R. So what I just want to say is that you can also have a data set which is in a test file. Then in that case, just control it. But what I wanted to show you is that when you save it in text, it comes with us, and there's a memory size. So the same data is now stored in Excel. Sorry, in text with that small size. Okay. So I think now we know how to read data into R. Later when we work, we'll see how if we have a data in R and we want to send it to, let's say, text or Excel, what do? We can actually write into Excel or write as a text file, or using write as a function. But now, today we've done a bit of abstract stuff. We must now get into practical stuff now. So, let's get back to our data. So the credit card. So we're going to do some stuff like sex is 1, 2, 1, 2, sex in there. If you look at it, it's also numeric, but should it be numeric? No. It's because of the way the data was. So we are doing it because a client may bring you data in your workplace. When they are collecting, they don't know anything about nominal, ordinal, whatever. Okay? They will just write, maybe if it's 1, 2, this 1, 3. But you, as the statistician who is working on the data, need to decide that if this is sex, then it must be under the nominal scale. So even though you have 1 and 2, it is not actually numbers, because I cannot add the first one and the second one will give me 4. What is 4? It doesn't make sense. So this is not numeric, right? So what should it be? It should actually be a factor that is under the nominal scale. So how do we do that? Well, we can do so that turn out to call factors. So factors, if we want to create a factor, we use factor. So maybe before we do this, let me call the anorexia. The anorexia data that use helper anorexia. You will see this. So the first and go down, the treat. Remember you saw control Days, that. So that's it. So it says that treat is what? Is factor of what? 3 level. Cont is control. CBT is what? Cognitive behavioral treatment. And LT is what? Family treatment. So the key thing is that this is what? Factor of 3 level. Okay. Let's do the insurance. Insurance. What about the insurance? In mass package, that's also a data frame. Let's look at this. Data frame containing column. District is a factor. District of resident or policyholder, 1 to 4 major cities. Group is what? Let's all look here. What is group? Ordered factor. So ordered factor is what? On the ordinal scale. Is that okay? Yeah, so this one, why is it ordered? Because factor, group of car with levels what? Less than 1 liter. 1 to 1.5 liter. 1.5 to 2 liters. If you are in the group, the last group, more than, let's say your car liter is 2.5, then it means the car runs faster than, let's say, 1.5 car. That's what it means. So this is graduated, right? So it should be what? It should be under the ordinal scale. Okay. So you see, in now it has been given to us, but you go obtain a data set. That data set is not in that format, but you know that this is what it should do. How do you get to that? That's what we are trying to do. Is everybody okay? Okay, good. Okay. So we need to call our credit card. So first of all, it's sex that we want to do. So converting numeric vector to a factor. So that's what we want to do. We call our credit card, then we put $sign in front. This is selection. This is part of the selection. So remember, we use the square bracket. We can also use the $sign. Okay, if you use the $sign, it only gives you the variables. Okay, especially for data frames. So what are we looking for? Sex, isn't it? Good. Okay, sex. Okay, so we do it like this. But this sex, we want to replace it. Instead of 1 and 2, we want to replace it with what? Male and female. And also make sure that they are all under the ordinal scale. So, sorry. Okay. So first of all, let's just do factor, and then we will come back and change it. So assuming we want to do factor, we will just copy the same thing and put it in there. So let's look at it. If you did not store your own, that's why I said don't give it that long name. When we are calling for it, you realize that your own is going way before. So let's do this. Now, if we go here and check, if we go here and check, you see, sex is now what? It's no more numeric, isn't it? It's turned to what? Factor with what? 2 level. Please, do you get what we are trying to do? Okay. Look at your credit card data. You will see that the sex is 1, 2, and it's numeric. But sex shouldn't be a numeric value. Is that okay? So what you were doing with levels of measurement, we need to, even though it's numeric, we need to scale it down to what? A nominal variable. That's what we are doing. And to do that, we use what? Factor. This one. What is that one? No, underscore. So you need more time. You need to select. So go back to this. Delete that. Delete the 6. No, delete the words. Put it. You go back. No. Use the tab. The tab 1. Tab. This one. This. Good. Okay. No. Put it here. You to select it from the assignment. The name from the assignment. Yes. Tab. Good. Have you start deleting that? No. Good. Put your A. Yes. No. On the A. Start deleting. Start typing. Wait. Select. Okay, so you still have so then and then the dollar sign. And then select. Your own is different. That's the problem. So you won't have, I think it's the second one. How do you do it? Yeah. No, it's your, I know what the problem is. Go back. So what you did, instead of this to be the heading, you didn't. So go and read the data again. So you have turned all your data into characters. If you check, all of the golden environment, all the data in your click on this one. No, don't click on it. You see observations on 9 variables, but they are all characters. Say what you want. You see, everything is character because of this mistake. So go back and import. So, let's ask you some. Your data is different. Let me see. Go back a minute. Yeah, go back. Delete the first one. Okay, delete it and save it. Delete it, yes, and then save it. And now read that here to work. So please, there's a mistake that you did. You see that your data is not like mine. Good, okay. You have to delete the first row. It's not anything. X1, X2. So please delete it in Excel and read it again into R. That's the problem. The first row is not needed. This one. So delete. No. I think you have done it. Yes, you did it. So you don't have it. Let me see. Yes, you go back. Go to the Excel. Hey. Please go back to your Excel, delete the first one. So this is 12. If you collect data and they have used 2 rows to name it, make sure that you combine it to one, because I will only read one rule as a name. So you see that all your variables were characters. Because of the first rule, you cannot combine. Yeah, you have to import. So save and you import. You delete and save it. The Excel, when you delete, you must save it. Otherwise, it will still be the old one. Then, yeah, but if you don't clean it, you can clean it, but it's let's just leave it. So, but if you delete it, please save it. And don't leave the empty line. It will also cause trouble. So you delete the whole row. Delete the entire row. So delete this one. This one. So you have to kind of make sure you don't delete the have you been able to read it?
Almost there.
Almost. Good. You should be there. So I sent a link on the page. If you go for the weekend, not the evening group. One is on bar chart, it's on YouTube. So please just go through it. Now that we know how data sets are and how to retrieve it, you can watch it and be able to practice it. Okay, so there are some videos on plot. We need to master it, but that's very important in statistics. And we can't do all that in class, so when you have you read it?
Yes, sir.
Let's see. So your credit card, okay, so delete this one. I read it. No, yes. You have to delete this, yes. The credit card is not loaded. Yes, so you have read the cards. So you can delete the default, they are all the default. So now it's okay. You see there. Yeah. Okay, so delete it. So cancel. You RN for that. So run RN. You do RN. You come back. Okay, so we all have it now. Okay, then you can change you are assigning the dollar. It's just after the credit card, then there's the, so this is also wrong. So you cannot assign 6. So if there's a credit card, then dollar sign. So delete that assignment statement the less than, and then put, you can limit this to copy, put the dollar sign. Then select 6. Now you are assigning that to 1 and 2. Just do average. Go to 0. So RM is removed. No smaller. And then the parentheses. Inside the parentheses. Start typing credit. And then select the no. You are selecting what you do. Credit underscore. The good one is the one. Delete this one. Don't type. Delete everything and start it. So conclusion. It's already highlighted, so you should just do it. Start like this. Take your time. Select one. Right, yes, you already know credit. So what you want to do? So there's no need to do this. So have you done this one? Do it, run it. Then you go. So please, have you been able to do the credit? You couldn't say a letter, at least says we should do. Which one? Let me see. You must check your, did you select or you type? Did you select or you type? Okay, so look at what I'm doing. If you don't do that, you always have mistakes. So let's say I want to change, let's say, education. Right? So I'll start, please look over here. You are not looking. Please, can we all look over here? Let's say credit, C card. I want to check education. You see, I'm not typing, I'm selecting. So I go to education. There's no way I'll make mistake. Okay. I now come here, I say factor. I take my time. You don't have to type so fast. Just start typing. I want factor, so I select. You won't make mistake. It puts it where you are supposed to write. So I start typing again. Credit. I take my time. I select this. What do I want? I want education. I put the dollar sign. So that's how I do it. So I may go, you may think I'm going fast. I'm not typing each of them. Is that okay? Okay, then I do this one. Okay, so when I go here, as for education and sex, I have created them into a factor. But I'm not done. Because for sex, I'm okay. But do I want to label it? Maybe I want to make sure that male is what? 2, female is 1. We have not done that. And it's good you do that so that when you say it, if they say 1, 2, you will know what that one is about. So let's see. Hey, time is up too. Okay, but if you add label to it, labels, then it means the first one will be 1. So if you want male to be 1, you put male here. And if you want female to be 2, what do? You put female. Okay. So if I rerun this, what happens? You go to sex, you see what? Male, female. Let me, is it too small? Look at sex. You see factor male, female, right? Yeah. So that's how you do this. For education, you can get the levels. They are 7, 0, 1, 2, 3, up to 6. Take your time and do it the way you want to do it. But you must add ordered as well. So that, because education is what? An ordered skill. And to be able to get it, you can also check the levels. They say 7 levels. So if you just do levels of education like this, it will give you all the numbers. So it's all 0, 1, 2, 3, 4, 5, 6. So what do you want 0 to be? Maybe no education. 1 is what? Some basic education. 2 is what? Basic education. 3, some secondary education, meaning the person is not finished. 4, completed secondary education. Then you go to some tertiary education, tertiary, something like that, and that should end up. But when you finish, you must add levels. Ordered is true, which means it will order it so that if you are 0, you tend not to be better than the person at what? Number 6. And that's it. What we wanted to do was to be able to do some graphs, but we don't have time. So I'll just demonstrate this to you, and I'll resend the link. Please take your time and go through it. So I want to check how many males and females are there. I can do table. How do I get? I have to copy this sex. So I'm getting what? These are, so there are 11888 males as against what? 18,000. Okay. Now, if I want to get their percentage, what do? I can just take this. So I can say this is frequency table. You know, you remember what frequency table is? Good. So this is a frequency table. Okay. So it means that if I sum the frequencies, what happens? If I sum the table, what will happen? I'll get a total number, 30,000, isn't it? Which means I can take the table and divide by the total, I get what? Frequency. If I multiply by 100, what do I get? The percentage. So if I want the percentage, I can just divide this by what? By that. So, sorry. So this is frequency table. And then here, it's what? Percent frequency table. You remember all those? Don't worry. You have the video and it is time. So I just have to move fast. Okay, so 100 times this. So almost 40% were all males, and what? 60% were what? Female. So that's what we do that. We can get a bar graph of this by using bar plot. I'll just use the frequency table. Okay. So like this. There it is. Okay. So this is bar plot. It doesn't look nice because the space is not good. Mercy. So this is where we want to get to. Okay, like that. I can color them. Maybe the first one I want it to be red. And R gives you red. The next one, what color do you want? You are a man. True. We can even sample from the rainbow color. So that's how beautiful R is. Okay, so these are the things we will be up to do. So I'll send you the link. You know how data sets are read and so forth. Take your time, just like I'm doing. We'll go through it. One of them is about pie chart. The pie chart you do, then there's also a 3D one, where you have the pie to be in a 3D form, and you can explode it, and so forth. So take your time and read and go through it. Next week, when we come, we will be doing some of this. Okay. Any question? Okay, so I'll make the video available to you later in the night. And then the scripts are also pasted there. And then I'll give you the link to the bar and pie chart. Please make sure that by the time you get here next week, you can plot. Because I'll do some exercise for 20 minutes. I'll give you a data and then I'll say you plot bar, pie chart. Explode it without using a board. But when you watch the video, how to explode it and so forth, you have to install the package called Plotrace. Yeah, but it's all in the video. So okay, so enjoy the rest of the evening and your weekend, and take care. God willing, we'll meet next week. Thank you.